Thanks, everyone. Hope you're ready to learn about how to make your traditional log tools work faster while requiring less hardware. It's really all about helping security and network teams ingest more data and to be able to finally utilize that data in an effective way in your environment. In short, I'll show you less than 10 minutes how to send more information to any log tool, but with less data to store. And that's really important. This means you don't have to leave any of that data on the network floor. All right, so a little bit about me first. I am a former Cisco engineer. Spent about 9 years at Cisco, 5 of those years as a distinguished speaker at Cisco Live, and about 20 plus years in the industry overall. So when you think about what a log or event management system should do, there were a few things that I learned along the way. One is that traditionally network management products don't actually solve problems, or SecOps products. They just point them out, and you get in your inbox 300 emails a day that you don't look at because who has time for that, right? So that was problem number one. Problem number two was about the speed of ingest, right? So how fast can I bring that data in? And here's the big problem in the industry. Companies claim to be scalable, but they're not. What they actually mean is that if you buy 250 servers, that they will scale. That's a problem for you because you have to pay for that. So we had to focus on this ingest. And our goal was to really lower the total cost of ownership down to a bare minimum. And we can do that by doing one of two things. One is this scalable engine that we've got. The second is on a deduplication algorithm, because in networks and security, there's a ton of duplicate events. All right. And so now that's where the log tools kind of stop. What about the next step? What about actually being able to enrich data as it comes into the system? So tying into multiple sources of information, such as a CMDB to get what's the SLA? Where is this thing located? Who owns it? Maybe it's a WAN interface that's gone down. What's a circuit ID? All of those things that somebody normally has to spend the time to look up, they now don't have to do it. It's in the event as it comes in. And then finally, a lot of times we know how to fix things, right? 70, 80, 90% of the things that come in on a daily basis are the same thing that we've seen over and over again. So let's take a look quickly at monitoring tools, right? On the left side, you'll see this is about 99% of where it comes in. And when I was at Cisco Live, I used to try to define with the crowd there what the difference is between monitoring and management, right? This is where they all seem to fall these days. On the management side, some of them are making the right attempts, but they don't actually manage it. The other thing is real time. When I say real time, I mean within a second, not within a minute or within 15 minutes, right? And then finally, as I mentioned, those scalability claims really are putting that burden on you to manage it. On the orchestration side, bringing all of these pieces together to be able to make an intelligent, informed decision is by far a much better thing for the engineers to handle and for the companies to pay for. A little bit about LZ Neo. I mentioned the real time. That's very important to us. When something comes in, I need to do a real time alert on it. In security land, if you even take a minute, it's too late sometimes, right? If we're trying to mitigate ransomware, the user clicks on an email, something happens to the registry, the disk gets written, the DLL gets written, and it starts scanning the network. If you're waiting more than a second or two, it's too late. So let's talk about the cost of logging products out there. What are we paying for this? If you look at the other products out there, the top two guys that are public now are Splunk and Elk. So we'll talk about one of those here. And here's the problem. You're paying for every single event that gets stored. And that's not just the event or the software license. It's the people to manage it, the servers. How much does it take to power it, to cool it, all of those things. And when we start to look at the cost of Splunk at large scale, up at 10 terabytes a day, it's actually around $80,000 a day between licensing and hardware and people and all of that. That's because of that scalability. Incidentally, the orange line is our operating cost. We can scale up to 30 or 35 terabytes a day, 40 if the server's fast. In comparison, the other guys out there get about 100 gigs per day per indexer, and 300 if you're lucky, but it's a far cry. All right, so if we break this down at 10 terabytes a day over 3 years, list price is $531 a gig, which puts you at about $30 million over 3 years, 254 servers, and a total cost of ownership of $109 million. Now, if you look at the gauges on the right, you're going to see that 531 per gig license skyrocketed to $11,000 per gig, which is absolutely insane, right? And if you look at the bottom here, you'll see all of the things broken down in detail. And of course, the most expensive thing is IT labor. So when you look at something like a free tool, it's not actually free. You're paying more for people to do it. Now, if you put us in front of it, here's one of the other things we can do. We can sit in front of all of these products and do our deduplication algorithm, do the event enrichment, and pass that information on. Those products lose nothing. In fact, they gain a lot more, and I'll show you that in a minute. But we bring this down to about 59 servers needed for Splunk and a cost savings of $84 million over 3 years. Granted, I'm sure some of you aren't doing 10 terabytes a day, but it's really irrelevant in terms of the percent that gets saved. It typically is somewhere between 70 and 95%. So we're going to take a quick look at a data storm. This is a real screenshot from a real customer. You can see some stuff blurred out. Their engineering team had pushed out a change. And shortly after, 1 billion events got generated. And you can see here it's one device, 70,000 events in 1 minute, 90,000, 62,000. And what happens in these environments is other products will either A, drop the event because they can't handle this sudden load, or they just go down to a crawl, right? And now you go to search and you're wondering what's going on. Everybody's scratching their head. And guess what? That's when you need that product to work and it's not responding. So 15 minutes later, you've got your results. 15 minutes later, somebody's in your network. 15 minutes later, core systems are down. But what if we just take that and deduplicate everything in real time and provide that immediate reduction in noise? So we can sit, as I mentioned, as a preprocessor to these downstream consumers, and everything comes into us. We do our deduplication, we do our fast processing. We essentially become that heavy lifter in front of any other downstream consumer of logs or SNMP traps. The major benefit here, not just in the cost, is that event enrichment at the same time, and the automation capability means you're, instead of making these products search for a needle in a haystack, you're handing them the needles. You're saying, here's what it is. I've pinpointed it. Here's every single thing you could possibly know about that affected entity. Now you do your job. The end result here is being able to lower the license cost of these systems, the hardware footprint, and guess what? Now they got faster. It's a lot easier to index one event than 1 billion, right? And then finally, I mentioned this earlier, we get this all the time. Companies will say, we don't log everything. We can't afford to. And my response is, you're not managing the network with the product you purchased to manage your network. So let's look at how this works. If we look at a screenshot here, this is LogZilla running. You can see here there's about 5 million events and 70% of them are duplicates. And we look on the Splunk side and you can see the exact same data coming in terms of what it can count, what it can collect. The counts are the same, but your license has gone down. We went from that 75 million plus events to 2 million, right? And our license uses and disk uses goes down. So then On the LogZilla side, it's as simple as setting up a forwarder. Out of the box, it does the deduplication, it does all the work. Everything's already pre-configured other than the forwarder, and you can see here it's a simple set the type, set the destination, the transport. You can set a buffer limit, so if the Splunk server goes down, it'll buffer it, and that's it. On the Splunk side, again, very easy to do. Add this to your Splunk transforms and props files, and you're good to go. And now you just saved your operating costs quite a bit, right? So I think we're almost at 10 minutes. I do have this running live. I think I'll take a second to show it to you. All right, so you can see an example here of a system that's running. There's events coming in for Cisco ICE and Firepower. And if we just look at the sample dashboard, this has the amount of events in here. And you'll see that there's about 4 million events in here running at 79% duplicates. On the Splunk side, if we go over here, we'll see there are 1.2 million events, right? So we have less events, the same amount of information in the events with that enriched data added to it, and the same counts coming out, right? And we'll go over here and look at our license usage. You can see that it's staying below our, in this case, free license. And I'm at 10 minutes and 20 seconds. So I think that's a wrap. Thank you, everyone.